Here's your Chapter 3 study guide explained. For Part 1, you are to solve each equation and make sure you show your work. When I zoom in on number 1, I see right away that it involves the distributive property. So that means we're going to multiply the outside number by both terms inside. 3 times 3m is 9m. 3 times negative 9 is negative 27. And then I bring down the 54. Now I have a two-step equation. I can solve a two-step equation by doing inverse operations. First, I undo addition or subtraction. Since there's subtraction, or minus 27, I add 27 to both sides. That gets rid of the 27. Now 9m equals 81. 9m means 9 times m. To get rid of multiplication, we do the inverse operation of division. So we divide both sides by 9. We can show that with a fraction bar. Now we have m by itself, and 81 divided by 9 is 9. So my final answer, m equals 9. Moving on to number 2, we have fractions. So you have a couple of different options with fractions. You could clear the fraction, or you could change them to decimals, or you could do common denominators. I'll show you the decimal version, and I'll show you how to clear the fraction. Let's clear the fraction first. I do see that 4, 2, and 8, those have something in common. We could multiply the whole equation by 8. Because since that fraction bar means divide, the inverse of division is multiplication. So this would be 8 times 1 divided by 4. 8 times 1 divided by 4 would leave us with 2h. 8 times 1 divided by 2 would leave us with 4. And these 8s would cancel out, leaving us with 6. Now we have a much easier problem. Use inverse operations, subtract 4 on both sides. Now 2h equals 2. And then our final step would be division. H is 1 for our final answer. So that's one way to solve this problem. It's called clearing the fraction. Let me show you how to do this same problem with decimals. And there are some common decimals that we could use. So 1/4, you may know, or you could do 1 divided by 4 in the calculator. 1/4 is 0.25. And that has a h there. 1/2, or 1 divided by 2, is like 50 cents, or 0.5. And then 6 divided by 8 is 0.75. So you could start off by converting them all to fraction or decimals if you're comfortable with that. It's still the same problem. Now follow inverse operations. So we're going to subtract 0.5, and we'll bring down our 0.25h, and this is going to be 0.25. Our final step would be to divide by 0.25 on both sides. And see, we get the same answer. H equals 1. So whether you want to attack this problem by clearing fractions and handling the fractions, or convert them to decimals, you'll get the same answer. Moving on to number 3, I see a multi-step equation, and I spot the distributive property once again. So we're going to distribute in the middle of the problem. Therefore, this 5f would just come down, And then we do 2 times 3f, which is 6f. And 2 times 4 is 8. So distribute first. I also noticed that we have like terms. So we have to combine like terms. 5f plus 6f, that's 11f. Now we're ready. We have a two-step equation, and we can solve our two-step equation using inverse operations. First, undo addition with subtraction. Now we have 11f equals 22. Our final step is to divide by 11. So f equals 2. Moving on to number 4. This one is similar to number 3 because we have that distributive property in the middle of a problem. So let's distribute first. We're going to do, oh, look at this like it's -4. So -4 times w, and -4 times a -1. Okay, so this 7w just comes down and hangs out for later. Okay, -4 times w is -4w. And then a negative times a negative, that's +4. Okay, so I'm bringing everything else down. Now, combine like terms. So 7w minus 4w, those are the like terms. That equals 3w. And now I've got it to a two-step equation. Use inverse operations. Get rid of addition first by using subtraction. We're trying to isolate that variable. And we get 27. And remember, 3w means 3 times w, so our final step is to show division. We show it with a fraction bar. So we're going to divide both sides by 3. And 27 divided by 3 equals 9 for our final answer. Okay, let's move on to part 2. Again, make sure you're showing all of this work, all of these steps. You're going to have to do that on the test as well. Okay, for the second section, you're identifying whether each equation has one solution, no solution, or infinitely many solutions. And again, it says, show your work. So let's start off with number 5 here. Okay, let's distribute first. That catches my eye right away. So we're going to distribute 6 times n is 6n. 6 times 3, or -3, is -18. And then I'm going to bring down all of my other terms. Okay, next step would be to combine any like terms. So I'm eyeing this up right here. And at -18 plus 6, that equals a -12. So over here we have 6n minus 12. Okay. Now, you may recognize that both sides are equal to each other, and we do have twins. So that should be hinting to you what kind of solution we have here. But let's continue to solve. Let's get our variables together next. So I'm going to take, because I'm going over the equal sign, I have to do inverse operations. Okay, now this is interesting because 6n minus 6n cancels out, becomes nothing, and then the same thing is true over here. 6n, oops, I made a sign mistake here. Okay, 6n minus 6n, okay, that also cancels out. All right, so now we are left with -12 equals -12. So we stop and we think, is this true? Does -12 equal -12? That's a true statement. And if it's a true statement or they're twins, we say infinite solutions. And we kind of talked about in class about being twinfinite solutions as well. Okay, so number 5 is done. Let's move on to number 6. Okay, we're going to have to do distributed property on both sides. So let's do 5 times 2a, which is 10a, and 5 times 2, which is 10. Okay, then on this side of the equation we have 2 times a, which is 2a, and 2 times -3, which is -6. Okay, now let's get our variables together on one side of the equation. Here's our equal sign. So we need to use inverse operations to get our variables together. Okay, so I'm going to move my 2a's over here because they're smaller. Okay, 10 minus 2 becomes 8a plus 10 equals -6. Okay, now this should feel comfortable because this is a standard two-step equation now. Let's continue to show our inverse operations to isolate the variable. So we're going to subtract 10 on both sides. So 8a equals, now be careful here, -6 minus 10 is -16. And then this means a coefficient next to a variable indicates multiplication, so our inverse operation is division. So we're going to divide both sides by 8. And a negative 10 divided by a positive, -16 divided by a positive 8 is -2 for our final answer. Okay, so what kind of solution do we have? We got a final answer. We were able to isolate the variable. So this is an example of one solution. So make sure you write one solution as well. Okay, moving on to number 7. Okay, no distributed property this time, but we do have to combine like terms. So I'm looking here, 3c and 4c. 3 plus 4, that's 7c. Bring everything else down. Okay, now let's get our letters together. So here's another example where our variable cancels out on both sides. And we're left with 9 equals -9. True or false? Does 9 equal -9? No. So this is a false statement. And false statements mean no solution. Okay, so if we end up with something that's not true, it's no solution. All right, one more of this type. And, okay, let's combine like terms first. So I'm looking over here. When we combine these, now these are on the same side of the equal sign, so it's -6 plus 12. So -6 plus 12 is 6x plus 2. And then we have 6x plus 12. This seems like it's going to be like the last one. Okay, let's get our variables together. And, oh, it happened again. We're out of variables. So we're left with 12 equals 2. True or false? Does 12 equal 2? No, that's false. If we end up with a false statement, we say no solution. Okay. All right, that front should be done. Okay, and you should have all of this work shown. Look at all of that work. Okay, let's turn to the second side. Okay, we're going to be doing some problem solving, and it looks like for both problems we have to define a variable, we have to write a linear equation and solve. So our first problem is about William and Sarah. William is X years old and Sarah is 6 years older than William. Their total combined age will be 36 years. So we have to define the variable. So what does the X mean? X is standing for William is X years old. So it just tells us right there. stands for William's age. Next, we have to write a linear equation. So we're going to use our variables. So we're going to take William. William is X years old. So that's William. And Sarah is 6 years older than William. Okay, so Sarah, you take William's age and add 6 to it. That's Sarah right here. Their total combined age, that's an addition problem. So we would add these two together, will be 36. So that's going to equal 36. So our equation, if I would write this simplified, I can leave it like this, or I can simplify this to 2x plus 6 equals 36. Okay, now we're going to solve the equation to find William's age. So let's solve this equation. We're going to subtract 6 on both sides. And we get 2x equals 30. And then our final step, inverse operations. So we're going to divide both sides by 2 to get x by itself, to isolate the variable. 30 divided by 2 is 15. So we said in the beginning, up here, that x is William's age. So x is 15. So William is 15. So how can we find Sarah's age? Sarah is 6 years older than William. So we're going to do 15 plus 6 to get Sarah's age. So Sarah is 21. Okay? Okay, so the key here is make sure you define the variable and you're able to write the equation, and then you use the equation to solve the problem. Okay, let's move on to the scooter rental shop, and there's a little typo here that's probably not in your paper, but the scooter rental shop charges $5 plus $2.75 an hour for renting, this should say a scooter. And Cassie paid $21.50 to rent the scooter. How many hours did she have the scooter checked out? So we're looking for the hours. So if you're trying to define the variable, look at the question. How many hours did she have it? So we could use the letter X. We could use a different variable. You could use H for hours. I'm just going to go ahead and do X. Is going to stand for the hours that the bike is checked out. Okay, let's create our equation then. So go back to the word problem. It says that the company charges $5 plus $2.75 an hour, and we said X is hours, and that Cassie paid $21.50. Okay, so that's our equation that we're going to solve. So I'm going to rewrite the equation here and use inverse operations to solve. Okay, so here's our variable right here. So I'm going to get rid of this 5 first. Use inverse operations, get rid of addition or subtraction first. Okay, so 275x equals, okay, so 2150 minus 5, that's going to be 1650. And now let's do that final step. So we're going to divide both sides by 2750 to isolate the variable or to get x by itself. And our final answer, when I do 1650 divided by $22.75, so x equals 6. So Cassie had the scooter rented for 6 hours because x equals 6. Okay, and that takes care of your study guide. Make sure you have all the work shown, and if you have further questions, let us know.